Alright, today's pretty basic. We talk about circles, and I know everybody knows what a circle is, but let's get an official definition of what a circle is. A circle, first of all, is two-dimensional, right? It's got length and it's got width, but it doesn't have any height, because if it did have three dimensions, it would become a sphere. So here's how circles are formed. You go from some point, anywhere you want to, in a plane, right? And you go the same distance away from it. So let's say we go 2 inches away in any direction you want to in that plane. So 2 inches away there, or 2 inches away this way, or 2 inches this way, or this way, or this way, or this way. And I could do this an infinite amount of times. And when I do it, wherever I end up, like these green spots right here, if I was to collect all of those, like the infinite amount of points right here that are 2 inches away from that original point, this circle would form right here. And that's an ugly picture, but you get the idea. Is everywhere that is the same distance away, which we call the radius, from this particular point right here, which is the center, a circle will form if that were to switch color. Right? So here's the center of the circle in red, and etc. So you get here, you can see this circle right here has center F. Realize that the center is not a part of the circle. The circle is only this green thing right here. So the circle is that, the center is F. To name a circle, right, you name a circle by its center. So there's a symbol for circle, so we don't have to write the word over and over again. So this is circle F. It's just like an O with a dot in it, circle F. You obviously know what a radius is. It's a segment that goes from the center of the circle to any point on the circle. So segment FB is a radius, segment FC is a radius, and segment FD is a radius. A chord is a segment with endpoints on the circle that doesn't go through the center. Like this green segment, segment AE, is a chord, and I don't like the way our book defines chord. They say anything with segments, any segment with endpoints on the circle is a chord. Well, I mean, that's probably right, but this blue guy right here is really a diameter, so I don't like to call that a chord. I like to just call it straight up a diameter. So radius goes from the center to any point on the circle. Diameter is twice as long as the radius, right, and it's got endpoints on the circle and goes through the center. And a chord right here is just a segment with endpoints on the circle. So let's do some example problems here. It says name the circle. Well, we name a circle by its center, so this is circle O. Name the radii of the circle, and I'm pretty particular. I personally like the segment's name to always start with the center of the circle. So there's segment OA. Now realistically, you could call it segment AO, but I don't like that, right? I like to start with the center of the circle. So segment OA, segment OC, segment OD, segment OB. Those are all the radii, which is plural for radius. And name the chords of the circle. In my opinion, that segment CD is the only chord in that. And you can call that segment DC. Remember, it doesn't matter what order you put the letters in. I just prefer that when you name a radius, you start with the center of the circle. That way you know it's really a radius, because it has to start from the center of the circle. So I'll let you do the first 3 problems right here. Why don't you pause the video and get the first 3 problems done here. And the name of the circle is circle R. There's 4 different radii. They're all starting with an R. Segment RA, segment RX, segment RB, and segment RY. And the 2 chords are segment AX and segment BY right here. Name the diameters of the circle. Well, that's segment AB is one of them, right? You can only use 2 letters. Don't call it like segment ARB or anything like that. And yes, you can call it segment BA. It doesn't really matter. And segment XY are the diameters of the circle. If the distance from A to B is 18 millimeters, so that is a diameter right there, find the distance from A to R, which is radius, so that would be half as much, 9 millimeters. If the distance from R to Y is 10 inches, which is a radius, find the distance from A to R. Well, the distance from A to R would be 10 inches, because it's also a radius, and the distance from A to B, that would be 20 inches. And notice how I'm writing the answer since there's more than one question. You can't put a segment bar above it because segments don't equal anything. The distances equal stuff. Is segment AB congruent to segment XY? Well, that answer would be yes. because they're both diameters of the same circle, right? They are diameters of the same circle. That's good handwriting right there. Of the same circle. Circumference is the distance around the circle. There's no such thing as the perimeter of a circle. There's two different formulas. Circumference equals 2 pi r, or circumference equals diameter times pi. The reason why they give you two different formulas is because it depends on what they give you. If they give you the radius, it's nice to use one formula. If they give you the diameter, the other. Well, so here they are. And the other one, circumference equals 2 pi r. There's the same thing, because 2 times the radius is really the diameter anyway. So they just have each formula for depending on what they give you. So here's how we roll. We got to start by writing the formula down first. I know you're going to get aggravated with that, but that's how we work. When things get a little more complicated, you'll thank me someday. So if they give me the radius and they want the circumference, I will use the formula with the r in it. And then we just got to put 3 in for r, and we can do a little bit in our head. We're going to take 3 times 2, and it says give both the exact and the approximate circumference. Well, the exact circumference is right here. It's 6 pi. That's it. Pi is a nasty number, meaning we'd have to round that thing off if we punch that in our calculator. So the exact circumference is 6 pi. Now for the approximate circumference, we will actually take 6 times pi in our calculator, and hopefully you can find your pi button. And this is an approximate number. It's a decimal. That's real nasty. It needs to be rounded off. So since they don't tell us how to round, we'll round to the nearest tenth, and we'll say that's approximately 18.8. And then the label is inches because it's just a distance. It's not an area. It's not a volume or anything like that, so it's inches to the first power. So exact with an equal sign and approximate with the squiggly approximate symbols. Let's do another one here. They give me the diameter this time. Circumference equals diameter times pi, so the circumference will equal 7 pi, and that is exact. And then we'll punch that in your calculator. 7 times pi will give me about 22.0 if we round that to the nearest tenth, so about 22.0 feet. Why don't you get number 10 and number 11 a try? Give the video a pause and get those two done. Start with the formula, substitute in. And hopefully you got these answers. Don't let that 3/4 throw you off. That circumference is just 3/4 pi. And then you can type in, 3 divided by 4 in parentheses times pi, or just change 3/4 to 0.75 since you're going to get a decimal anyway. But that's when they give you a diameter or radius. Here they give us the circumference, right? It says they give you the circumference. Round to the nearest hundredth, they want us to find both the radius and the diameter. So they give me the circumference of a circle. You will start with the formula for the circumference of the circle. It doesn't really matter which one, since they want the diameter and the radius. I feel it's much easier to start with that. So you'll learn that if they give you something and you have a formula for it, you should start with that formula. So we can put 40 in for the circumference and solve for d. Well, to get d all by itself, we just divide both sides by pi. So d equals 40 over pi. And that's the exact diameter. Now we'll punch that in, 40 divided by pi. And they want us to round to the nearest hundredth, so that would be 12.73. But keep that dirty number in your calculator. It's about 12.73 inches, because they also want the radius. So instead of taking 12.73 and divided by 2, we'll take this dirty number and divide by 2 and get 6.37 for our radius. So the radius is about 6.37 inches. Then I'll do one more with you, because I don't like the way I wrote all this backwards, So we'll start with the formula. They give me the circumference. 256 goes in for C, and then I want to solve for d, but I'm also going to use the old symmetric property and pull the old switcheroonie. I'm going to make all this stuff switch over here. So when I solve for d, it's going to be 256 divided by pi. And that is approximately, if we punch that in to the nearest tenth, 81.49. And then keep that dirty number in your calculator and say the radius is about that dirty number divided by 2, which is 40.74 feet. So the only new thing that I did on this step was I kind of made them switch sides over here so that way I could read it from left to right, etc. So why don't you do the next 4 problems? Give the old video a pause and get those bad boys done for me. So I know it gets annoying writing that formula down every single time. It's like, dude, I get it. Aren't we just taking this circumference and dividing it by pi and getting an answer? Well, yeah. I mean, obviously you figure that out when you do 6 problems in a row. But when they mix the problems up, you know, especially next chapter when we do the volume of this and the surface area of that and the lateral area of this, you know, you start by writing the formula down, you substitute in and solve for what's missing. So that's the process that we go through here. Find the exact circumference of each circle using the given inscribed or circumscribed polygon. Well, you can see that we have a right triangle inside of a circle right here. Well, we can do the old Pythagorean theorem to solve for d, right? But remember, there are 3 very special right triangles that I'd like you to have memorized. One is a 3, 4, 5 right triangle. Another one is a 6, 8, 10. And the other one is a 5, 12, 13. If any of these right triangles show up, we know that that will hold true. Like 3 squared plus 4 squared equals 5 squared, where the largest number of these is the hypotenuse. So if the hypotenuse is missing, like it is in this case, this is 6, this is 8, we know that that's got to be 10. And that is also the diameter of the circle right there. So that's very, very handy. So the circumference will equal diameter times pi. You start with the formula. The diameter is 10, so the circumference equals 10 pi. And they say only find the exact circumference, so boom. 10 pi centimeters. We're not going to punch anything into our calculator because that would be approximate. Here, this is an isosceles right triangle, which is also 45, 45, 90. So we have a leg of 9, meaning that the hypotenuse is 9 square roots of 2, if my pen would write, because that's a rule that we have memorized. So the circumference equals diameter times pi. The diameter is 9 square roots of 2, but the radical always has to come last. So instead of having 9 square roots of 2 times pi, we just don't like to write it that way. We're going to do the old commutative property and make some stuff move around and always save the radical for last. So there it is. There's our exact circumference. Here, this is a rectangle. I can't really prove that to you until you learn more about circles. Our book kind of went out of order here, but this is also going to be 90 degrees. So this is not one of them special right triangles, so let's call the hypotenuse of this d, since it really is the diameter of the circle also. Let's do a little 3 squared plus 7 squared equals d squared. 3 squared is 9. 7 squared is 49. And add those together and get 58 equals my diameter squared. So the diameter equals the square root of 58. Right there. And then the circumference equals diameter times pi, and diameter comes last, or sorry, the radical comes last, so circumference equals pi square roots of 58 millimeters. And here, don't make this any more complicated. This distance out here is 11 yards. So this distance right here, if I had drawn that a little bit better, which is the diameter, is 11 yards. So circumference equals diameter times pi. Circumference equals 11 pi yards. That's the exact answer. 5, 12, 13. Circumference equals diameter times pi. Circumference equals 13 pi centimeters. And this is also a 45, 45, 90 because it's isosceles right here. So this is the square root of 2. For a leg, I need to take it times the square root of 2 to find the hypotenuse, and that will give you the square root of 4, which actually equals 2, because 4 is a perfect square. So circumference equals diameter times pi. Circumference equals 2 pi centimeters. That's the basics of it. Let me know if you have any questions, and have a good one.